Well-designed pump sumps save you time and money. Mistakes in pump sump design are not only a costly way of running a pump station lifecycle-wise, but rectification costs involved at a later stage can also prove to be very costly. Therefore, it's best to design the pump station correctly from the beginning. A proper design of the pump sump for sewerage and stormwater systems is crucial. Two important design requirements to be met are preventing significant quantities of air from reaching the impeller and disposal of settled and floating solids. Operating costs can be reduced with the help of effective planning and suitable operation schedules to achieve optimum pumping performance and maximum pump life. Pumps are used for many different purposes: drainage, circulation, distribution and pressure boosting systems, each having different installation methods. For wastewater, pumps are installed in a sump. How would you describe the purpose of the pump sump?
It's the traditional way of installing a wastewater pump. The pumps are started and stopped at well-defined water levels, often with uncomplicated level switches, ensuring robust and reliable pump control and sump operation.
Could you describe the requirements of a well-designed pump sump?
There are four crucial hydraulic requirements to ensure correct flow into the pump inlet. Firstly, to prevent pre-swirl. Secondly, to minimize velocity deviation in the pump inlet. Thirdly, to avoid vortices, surface, bottom and wall. And finally, to prevent significant air entrainment.
What will happen if these criteria are not fulfilled?
Lack of uniformity can cause the impeller to operate away from the optimum design condition and therefore at a lower hydraulic efficiency. Unsteady flow causes the load on the impeller to fluctuate, which can lead to noise, vibration and bearing problems. Swirl in the pump intake can cause significant change in the operating conditions for the pump and can produce changes in the flow capacity, power requirements and efficiency. It can also result in local vortex type pressure reductions that introduce air cores extending into the pump. This and any other air ingestion can cause reductions in pump flow and fluctuations of impeller load, which in turn results in noise and vibrations leading to physical damage of the pump. Additionally, these fluctuations can impact process loads in other parts of the system.
Are there any other special requirements for pumping wastewater?
The design of a sump should not only provide for proper approach flow to the pumps, it should also prevent the solids in the wastewater to accumulate on the sump floor and surface scum in the sump. Sediments cause sulfuric gases, harmful for the environment and equipment inside the pumping station. Some of the solids float on the surface. Improper sump design and pump control can cause buildup of a mat on the surface. When the mat breaks up, large pieces might enter the pump inlet, causing disturbances in the pump operation. Those problems can be avoided with correctly selected pump control and good sump design.
ITT Flygt has developed a number of sump designs according to these criteria. For example, the central front high-level entry design type A1. A specially designed baffle wall minimises the air entrainment due to falling water. The flow from the inlet pipes impinges on the baffle wall and then flows down into the inlet chamber through the slot in the floor of the baffle. This slot distributes the flow evenly towards all the pump inlets with a minimum of pre-swirl. Equipping the sump with splitters and benching are often beneficial for pre-swirl and prevention of sediments. If the piping system and the sump location do not allow for a front entry inlet, a side entry inlet with a baffle wall modified with ports can be used. This configuration, that Flygt has also invested significant research into, is referred to a type A2. In this design, the baffle wall redirects the incoming flow and distributes the flow evenly towards the pump through the ports. Finally, in this arrangement, that Flygt designates as type B2, has a straight baffle wall. Either the sump or the sewer is below the normal water level in the sump, or an open channel supplies the sump. In the absence of falling flow into the entrance, no intense entrainment of air takes place. Consequently, the inlet chamber can be greatly simplified because its only task is to distribute the flow evenly to the pumps. Close to ITT Flygt headquarters, the company Nordenergi produces district cooling and heating. In the summer 2002, two CP3312s were installed in a pump sump designed by ITT Flygt. Here, treated effluent from the wastewater treatment plant in Broma is pumped to the heat exchangers to utilise the temperature energy available in the water. This pump station consists of an inlet chamber and a type A1 sump design. The inlet chamber allows the water to enter the sump via two ports. The baffle then deflects the flow. The flow is directed towards the pump by these walls, which also support the baffle. To achieve optimum pumping performance, reliable duty and long life, not only high quality pumps are needed. Optimal hydraulic conditions are also required. Using Flygt's extensive research and development experience in tested sump designs guarantees an overall reduction in total life cycle costs. Pump maintenance is reduced as the pumps run smoothly, free from excessive vibration and air entrainment. Station cleaning and maintenance costs are reduced or eliminated as sediment problems and surface crust build-up can be avoided. Environmental concerns play an increasingly important part in everyone's lives. Reliable wastewater pumping will contribute to a better world to live in.